Dear viewers and subscribers, we have discussed a lot about VM, Azure Virtual Machine, and also VM types. Our last topic was Azure Virtual Desktop, which is also the type of VM. We have discussed that virtual machines are an excellent way to reduce costs versus the investment that are necessary for physical hardware, right? Limitations. So what are the limitations of virtual machine? Actually, virtual machine uh, is per operating system. What number of virtual machine you have to manage your operating system with those numbers. If you have to create 5 virtual machine, definitely you have to manage 5 operating system. Each virtual machine have its own operating system. Now, if I want to run multiple instances of same application on a single OS, then what is the option? Okay, it is the Azure Container. Guys, let's watch this video to understand VM and container in more detail.
In this video, we'll discuss the difference between virtual machines and containers. So let's begin. Deploying server applications has always been complicated. That complexity drove system admins to start looking at virtualization techniques like virtual machines and containers. Virtual machines, or VMs, provide an abstraction layer for CPU, memory, and storage. They can be changed without having to invest in new hardware while still allowing the environment to be flexible and secure. With VMs, you're in control. You decide the operating system, install tools and packages, and your app runs either in isolation or with the other apps you install into the VM. But there are downsides. VMs can only run one operating system at a time. So if you have multiple server apps that all require different runtime environments, they may also require multiple virtual machines to execute properly. And because the VM is emulating a full computer, tasks like starting one up or taking a snapshot are pretty slow, often taking several minutes. But there's a lighter weight solution that solves some of these issues: containers. A container bundles a single app and its dependencies, referred to as containerizing the app, then deploys it as a unit to a container host. The container host provides a standardized runtime environment which abstracts away the operating system and infrastructure requirements, allowing the containerized application to run side by side with other containerized apps. An easy way to differentiate between VMs and containers is virtual machines virtualize the hardware, while containers virtualize the operating system. The operating system level virtualization of containers is one reason why the container approach is more efficient than a full virtual machine. It allows you to run multiple lightweight containers on a single host without sacrificing the isolation that the virtual machine originally offered. Azure supports several container variations, the most popular being Docker. Unlike VMs, you can spin up containers quickly. You're just waiting for the app to launch instead of both the operating system and the app. Also, containerized apps tend to be much smaller in size, and the development process is simplified because your development runtime environment can look exactly like the production environment. Another advantage to containers is that they can be orchestrated with container cluster orchestration. You can easily deploy and manage multiple containerized applications without worrying about which server will host each container. The decision of whether to use a VM or container depends on how much flexibility you need. If you need to completely control the environment, then you might choose a VM. If not, then the portability, performance characteristics, and management capabilities of containers might be the better choice.
Okay, great. Guys, in this example, you can see that we have virtual machine architecture on both sides, right? And you can see then we have host operating system, Then we have hypervisor and on right side Docker engine. So this is the difference because we have now monitoring through hypervisor every guest operating system. And here we have only Docker engine. On Docker engine, which help us to virtualize the operating system. Mean you can see on right side that we have apps with dependencies, libs and some other dependencies within one container. Let's suppose we have some dependencies within one application and that is virtual machine. Definitely we will not be able to uh, run another application if there is any conflict within those dependencies. We have to create another VM where we have to provide another disk space for dependency maintenance and also memory, processor, each and everything. But container help us to virtualize operating system. We don't need to do anything apart from this. I believe you have understand in with from this image what is the main difference apart from this video. Let me also show you the differences in a chart. We can see it's lightweight, but VM is heavyweight, limited performance. Each VM run its own OS, hardware level virtualization, but container do so operating system level virtualization. Startup time, it also matters. Allocates required memory, fully isolated and hence more secure. So these are the major different, although there are a number of more difference, but in different aspects. So we also discuss the what else actually Azure provide us. It also provide us like Kubernetes services. Azure Kubernetes services is a container authorization service. Let's suppose if you want, we want to manage number of containers, then how we can do that? It's a Kubernetes services provided by Azure service. Uh, Containerization is also solution when we go for microservice level architecture. This architecture is where you break solution into smaller independent pieces. For example, you might split a website into a container hosting your front end, another hosting your back end, and a third for storage. So this split allows you to separate portions of your app into logical sections that can be maintained, scaled, or updated independently. Imagine your website backend reaches capacity, okay, but the front end and storage are not stressed. So it's mean we have problem with only one container containing backend services. With with that container, you could scale and backend separately to improve performance. If something necessitated such a change, you could also choose to change the storage service or modify the front end without impacting any other component. So, guys, this was for today Azure Container, and tomorrow we will be discussing Azure Function. Okay, so stay connected and please don't forget to provide your feedback. Because I'm trying to provide my best, I do some research on different and do some R&D on different blogs and websites for you, and definitely you go through my video and see what is the improvements you need in further coming videos. So I will try my best. Please don't forget to provide your feedback and always stay connected with Max the service to support and love. Thank you. Bye.